Alright, let's try to get this a little bit better here. Sorry guys, I don't have a decent program to record the screen on the laptop here, so I'm going to try my best just to use my camera stand here. So as you guys are going to figure out here, I do play around a lot with, I play a lot with car audio and stuff like that, and in recent days I've taken it upon myself to learn a little bit more and exactly how this stuff works out in the best fashion possible. In my time, I found out that probably one of the most crucial pieces or components of your sound system is definitely the box, the enclosure that your subwoofer sits in. I'm going to show you guys the program that I use, and I will give you a little bit of information on how that works. If I see some comments and stuff and you guys want to know a little further into how to use this particular program, I'm more than happy to go ahead and throw some videos together to show you what I know. I'm not a professional with this program. I know some very basic stuff just from the research that I've done, but we'll go and just throw this stuff in the video for you guys for hopefully a one-spot shot of figuring out what everything is here. So first off, I'm just going to open up the internet here and I'm going to show you. This is winISD. winISD. It's by Linear Team. This is the program that I use to actually design my subwoofer enclosures. Now, this is not a CAD program. This is not a program that you use to actually create 3D models of a subwoofer box. This is a program that uses the TS parameters, or the Thiel small parameters of a subwoofer, to graph what its behavior will be like in an enclosure with a specified square footage and tuning frequency. So this is just their site. It's linearteam.org. You can get it. This is a free program. It's been available for about 10 years. They got their latest version up here. You can see it's from 2016. So these guys are still actively working with this program. Like I said, it is free, but they do appreciate the donations. Donations help in the fact that these guys can make this program a little bit better. It's a little bit more of an incentive for these guys to actually put a little bit more work into it and make it better and better for us to use this. So this is, again, like I said, this is going to be the website, linearteam.org. All I did was just Googled it, winISD, and right away at the very top is where it is here. So I just get the software right off their website, so you don't have to worry about any of the bullshit websites trying to get you to do surveys and things like that to download for free. So we're just going to go ahead and open up winISD. And here it is. I have actually changed the background color of the graph. I found that I prefer the green. It's a little bit easier on my eyes when I've been staring at this program for a solid minute here. But when you open up the program, this is what you're going to see. It's automatically in the transfer function magnitude graph here. It's an empty graph because I do not have a subwoofer in here. I do not have an enclosure specified or anything like that. So I'm just going to show you guys a real basic run through of how exactly this works. In the case of you're working with a new folder here, or a new file, what you're going to do is you're going to go up to the upper left hand corner. You're going to go to create new project, click on that. It's going to pop open a list of different companies. I myself, I run Digital Designs equipment here, so we'll actually just go and get this a little bit closer. I run Digital Designs. They did not have the information, the TS parameters, in their database right away, so this is actually some stuff I had to add. In a different video, I'll go and show you guys how to add subwoofers and stuff like that, but in this case, we're going to utilize the 715D2. And it's going to say driver data integrity checks OK. You're going to hit next. Then it's going to ask you the number of drivers. In my case, let's just say 1. It's got a normal placement. Isobaric just means that there's 2 subwoofers and they're mounted face to face. They do kind of a push-pull thing. So as one subwoofer goes out, the other one goes in. And as one goes out, the other one goes in. So you get this what they call isobaric, or compound. So in this case, I'm doing normal, so just 1 driver. And we're going to click next. And then it's going to ask you the type of box here. So in this case, we're going to do vented. DD Audio does not recommend doing a closed box or a sealed box. They recommend vented or 6th order band passes. In this case, we're going to do event. You got a nice photo here to kind of show you what exactly you're looking at. Click next. I do not mess with this. Leave it at Chevy Chev. Whatever alignment they choose for you, leave it at Chevy Chev. The Chevy Chev box design just describes that the transfer function magnitude, it's going to be a little bit less of a peaky response box. It's going to be a little bit more of a flat response box. And I'll get a little bit more into that information here in a sec. We're just going to click next. And you'll just type in your project name. In this case, I'm just going to type in some random stuff here and create. And then right here is going to be the function magnitude right away. So I'm just going to go and set this back down so you don't have to deal with my shaky hands. So at the very, very top here, again, you got the transfer function magnitude. You can see it highlighted underneath my pointer here. They have a bunch of different options. These are all different things you can view under graph. Projected SPL, what it's going to be at, and things like that. Cone excursion, this is how far out the cone's going to move. Rear air velocity, this is just how much or how quickly the air leaves the port in this case. Impedance graphs, it shows you your box rise, so this will be the impedance rise of the subwoofer as it is running. Let's see what else. For the most part, I mean, those are the main things that I play with. It's going to be your transfer function magnitude, your SPL, cone excursion, and the rear air velocity. Those are the main things that I use when it comes to building a box. Those are really the only things I really know about too much on this. So what I'm going to do is I'm actually going to close this down, and then nope, do not want to save. And I'm going to go ahead and open up a project that I've been working on for a little while here. So if you want to open a previous one you've been working on, you're just going to go up to Open Project, and you'll just select the project which you're working on. And I'm going to go ahead and grab this one's the box that I've been working on designing here. And this is going to be the transfer function magnitude here. Okay. And you got different options in the bottom here, in the bottom left hand corner. You've got, you know, driver, box, vents, filters, signal, advanced in the project. What this does is it allows you to change the cubic footage of the box. So this is the cubic footage of the box. This is actually what winISD recommended me go with. So this is the first time I'm actually going to take their recommendation. Normally I change this value to make it a little bit more friendly for my application, but in this case I'm just going to accept their value and I'm going to run it the way they say I should. In this case they recommended a 9.075 foot or cubic foot box at 21 hertz for a tuning frequency. In here, this is where you can actually design your port. You can select either round or square, and then you can actually change the dimensions. And what it's going to do, according to the dimensions you input, will change the vent length. So you can see here, this is with a 12-inch round port, one of them. They're telling me that 67.06 is the length that I would need in order to achieve 21 hertz. But yeah, this is just going to show you the vent length in this case. So we're just going to change this value real quick. I'm going to show you guys how this is actually going to change. So we're going to go to a 6-inch port, and you notice now it says it's saying 14.57 inches. So it does all the calculations for you to understand that, you know, if you're working with a box and you're asking for 21 hertz, when you start changing the variables here for the port, it'll actually tell you exactly what the length should be. So you can input filters, what kind of filter you're using. I actually use a 40 hertz filter right now for a low pass, but I was just playing around to see what other filters would look like. Signal, you can tell it what kind of wattage you're planning on running, the resistance, the angle of the sub, how far away you're listening to it. These are actually, this is very interesting. You can actually give it the current temperature, humidity outside, and the air pressure as well to get a little bit more of an accurate feel as to what it's going to do. And then this is just information about the project. So you can type your name in as creator and describe exactly what's going on there for your own sake. So For the sake of, I'm just going to leave this video a little short. I will make a couple of more videos of exactly how this program works for you guys' sake, so tune in.